Okay, now I'm going to generalize what we talked about in the previous chapter from 2x2 matrix games to m/n matrix games. We're going to start with a 2x3 matrix game. Now, the procedure for a 2x3 matrix game is very similar to the procedure for a 2x2 matrix game. But let's take a look at what we would have. We would have a game matrix. We would have a strategy for P, a strategy for Q, and a game value as follows. Now, the first step would be to add the value K. So we want to add a value K. We're going to convert it to M1 by adding K to it. So we will take this matrix, or the matrix here, and we'll add this matrix up here. We'll add K to it, and we'll get this matrix. Okay. Now then, after we set that matrix, we're going to use the coefficients from M1 to set up a minimization problem and its dual maximization problem. And I'll talk about that when we get there. And then we'll solve these two problems. And then once we solve the two problems, we'll know x1, x2, and y, as well as z1, z2, and z3. And then we can get the values for v1. And then once we get v1, we can subtract the k from it to get back to the value of v. And we can also get the values, the strategy for P, by multiplying v1 times x1 and v1 times x2, and the strategy for Q by multiplying v1 times each of the z values. And then you could also check it if you wanted to. So let's look at a game here. Okay, this investor elects to invest $10,000 in stocks and bonds. Now he knows that the return on the investments will be affected by the change in interest rates. He estimates that the return, now that remember this is in thousands of dollars at the end of each year, will be indicated as below. So this matrix here represents the return based on the change in rates. So if there's a 0% change, he expects a return of 1,000 or in stocks and minus 1,000 in bonds. If there's a 1% change to the positive, he expects to lose 1,000 in stocks and gain 2,000 in bonds. If there's a minus 3% change, he expects 6,000 in stocks and minus 3,000 in bonds. So let's assume that the market is a clever player and will play to reduce our investor's return as much as possible. And let's find the optimal strategies for the investor and the market, plus we'll find the value of the game. Our first step is to take the matrix M and make sure that we add a number to it so that we'll get all positive values. Well, -3 is the most negative number, so I know if I add 4 to that, that will convert all the values to positive. And this will be actually M1 once I do that. So add 4 to each of these numbers, and if you add 4 to each of these numbers, you'll get this new matrix for M1. And then if you read, if you go back up here and look at the coefficients, notice that the coefficients for the minimization problem, notice that the coefficients are A1, B1, A2, B2, A3, B3. So the coefficients for the minimization problem are just the column coefficients. And then over here for the maximization problem, it's A1, A2, A3, and B1, B2, B3, so that's just the rows. So we just take each row. Now, so the column from over here, remember we've got to use this matrix. So the columns are 5, 3, 4, 6, and 10, 1. So I'll have 5x1 plus 3x2 is greater than or equal to 1, 4x1 plus 6x2 is greater than or equal to 1, and then 10x1 plus 1x2 is greater than or equal to 1, and then of course your non-negative constraints as well. And for the maximization, you use the row coefficients. 5, 4, 10 will be the first set of coefficients. So 5z1 plus 4z2 plus 10z3, and remember this is less than or equal to 1. And then here you have 3, 6, 1, so 3z1 plus 6z2 plus z3 is less than or equal to 1, and also you have your non-negative constraints. Now, remember to solve this dual problem here, to solve this dual maximization problem, we actually have to add the decision variables from the original minimization problem, we have to use these as slack variables. So we'll take this first constraint and we'll add x1 to it to convert it to an equation, and then we take the second constraint and we add x2 to it to convert it to an equation. And then we take our objective function and we move all of the terms to the left and they'll change sign. Now remember, once we get this initial system of equations, we can write this initial simplex tableau for the dual method. Now the pivot column, remember, is the column that has the most negative indicator on the bottom row. But since all three of these negative indicators are the same, I can choose either one, so I'll just choose the first column. Now if you take 1 and divide it by 5, you're going to get 0.2, and if you take 1 divided by 3, you're going to get 0.333. So since 0.2 is the smaller quotient, I'm going to pivot on this row, which means I'm going to pivot on the 5. Now I'm going to dispense with going through the mathematics here, but I will tell you, how you go from step 1 to step 2 here. You have to do 3 row operations. First, you have to multiply row 1 by 1/5 to convert this to a 1. And then after you convert all of these by multiplying by 1/5, then you multiply this row by -3 and add it to row 2 so that you'll get a 0 down here. And then after that, you take row 1 plus row 3 and add it, and you'll get a 0 there. Now if you do those 3 row operations, then this is the new tableau. Now in this tableau I only see one negative indicator, -2/5. So this has to be the pivot column. Now I just took a calculator and did 1/5 divided by 3/4, and I got about 0.27, but when I took 2/5 divided by 21/5, I got a number very, very small, like 0.09 something. So that's the smaller quotient. So this would be the pivot row. So now if I'm going to pivot on this column and this row, this 21/5 here would be the pivot element. So now what I've got to do is multiply this row by the reciprocal of 21/5, which is 5/21. So multiply everybody in that row by 5/21, and then that way this will become a 1. And then after you do that, multiply this row by -3/4 and add it to row 1 to cancel the 3/4, and then multiply it by 2/5 to cancel the -2/5. Well, now we would get this matrix or tableau, and this tableau is the final tableau because I have no negative numbers on the bottom row. Well, there's 2 sets of variables here I want to look for. Let's look for the z values first. If you look at this column, you have a 1, 0, 0. And if you look at this column, you have a 0, 1, 0. And those are basic variables. And the only other basic variable is here, 0, 0, 1. So these guys must be non-basic. Okay? Now, they're not really all 0 though, because remember x1, x2, we find those in a special way. But for now, in order to find the z's, we'll assume that these 3 are 0. Well, if these 3 are 0, then we can now read off the solution for z1. z1 would be 1/7. The solution for z2 would be in the second row. z2 is 2/21, and the 2/21, and y would be 5/21. So I know y is 5/21. I know z1 is 1/7. I know z2 is 2/21, and since z3 is non-basic, it must be 0. Now let's return to x1 and x2. Remember, to find the values for the original minimization problem, we actually look at the bottom of these columns. So x1 is 1/7 and x2 is 2/21. So there's x1 and there's x2. And of course the minimum and the maximum are the same in both problems, y equals 5/21. So to find v1, remember, it's just 1 over y, and since y is 5/21, 1 over 5/21 is 21/5. And then remember, we added 4, so we have to take 4 away from that, and we get that v is 1/5 when we take 4 away. And then remember, to get the strategy for P, we have to take V1 and multiply it by each X value. So V1 is 21/5, multiply it times a 7th, and I get 3/5. And then take 21/5, multiply it by 2/21, and I get 2/5. So that's the strategy for P. The strategy for Q, I take each V1 value and I multiply it by each Z value. Well, Z1 is 1/7, so 21/5 times 1/7 is 3/5. And then Z2 is 2/21, so V1 times Z2 is 2/5. And then Z3 was 0, so 21/5 times 0 is 0. So therefore, that's the strategy. Now, the conclusion is that if the investor will split the $10,000 at 60% and 40% proportions, then he will invest $6,000 in stocks and $4,000 in bonds. Then, regardless of the market rates, as long as the payoff payoff does not change, the investor will be guaranteed a minimum of 1/5 of $1,000, which is $200, and he might even fare better. Okay, so that's part A. Now, part B says find the expected value of the game if the investor continues with this optimal strategy and the market value switches to the following pure strategies. Okay, so once I do the 0% change, I think you'll figure out how to do the other two. The 0% change would be right here. So to get the 0% change, it's kind of interesting what we do since that's in the first column. Here's what we're going to do. Okay, what we're going to do to find the expected value, remember the expected value is P times M times Q. Well, we know P is 3/5, 2/5. We know M was this game matrix, and Q is going to be a column matrix where you have a 1 in the first entry because that's for the 0%. And if you multiply these three together, you get a single value, 1/5. So that means 1/5 of the $1,000, which is $200. Now, if you go to the plus 1% change and multiply this, I took this matrix times the game matrix, and then the Q matrix, the 1 has to be in the middle for the middle value, the middle return, which is plus 1%, and I got 1/5 again, which of course 1/5 of 1,000 would be 200. And then for the negative 3% change, you do exactly the same thing, multiply the strategy matrix times the game matrix, and then 0, 0, 1, because now you're looking for the negative 3% change, and that gives us 12/5 of 1,000, which is actually 2,400. So the minimum earned is $200, and in the third case, he would expect to earn $2,400. And so I realize that this is a confusing process, and you might want to review this if you take a course later that involves game theory. In the next video, I'll go ahead and actually I'll just go ahead and show you this one, and you can freeze the video rather than do another video. So here's another example with just a different game strategy, and I'm going to go through the same process. I'm going to add a number, add 4 to each of those so that I don't have any negatives, and then I'm going to use the columns for my coefficients in my minimization problem. I'm going to use the rows for my coefficients in my maximization problem, and I'll let you solve this by the dual method. I didn't actually go through that. I figured you could go through that and solve it by the dual method, but here's the solutions that I got for both. And then I just went to those formulas that are earlier in the page to find the different values for P, Q, V1, and V. So that, again, you can freeze the video and then work through this problem if you want to as practice. And again, this can be extended to more than just a 2x3 game, but that's as far as we're going to go in here. Good day.